Water, water everywhere. But how does it behave in the vast expanse of space? Have you ever wondered how water behaves in space? It's a fascinating phenomenon. It's very different from down here on Earth. On our planet, gravity pulls water down, making it flow and settle. Out in the cosmos, gravity doesn't hold things down like it does on our planet. This changes everything about how water moves and behaves. This means water floats around in a really cool way. It forms blobs and spheres, defying the usual rules we know. Imagine a big shimmering blob of water just drifting by. That's what it's like. It's mesmerizing to watch. We need water to survive, even in space. It's essential for drinking, cooking, and maintaining life. Astronauts need to drink it, use it for hygiene, and keep themselves clean in the confined space of the ISS, and even grow plants with it. Water is crucial for experiments and sustaining plant life in space. But managing water in a zero-gravity environment is tricky. It requires special systems and careful handling. Let's dive in and explore the fascinating behavior of water in space. It's a whole new world of physics and science. It's all about physics, you see, things like surface tension, adhesion, and how water clings to surfaces. And cohesion play a big role in how water acts when it's free from the pull of gravity. These forces shape its behavior. So buckle up, space cadets, as we embark on a journey to uncover the secrets of water in the final frontier. Get ready for an adventure like no other. Floating in space. It's all about microgravity. Let's dive into the fascinating world of microgravity and understand what it really means. Don't let the big words scare you. It's simpler than it sounds. Microgravity just means very weak gravity, almost like a gentle pull. On Earth, gravity pulls everything towards the center, which is why things fall down when you drop them. But in space, things float. Water behaves differently too. Because there's very little gravity in space, water doesn't flow downward like it does on Earth. Instead, it floats around. Instead, it forms into spheres, almost like tiny planets of water. It's like magic, but it's really just science at work. The lack of gravity changes everything. Imagine trying to pour a glass of water in space. It wouldn't work the way it does on Earth. The water would just clump together in a big wobbly ball, floating around. That's why astronauts use special pouches and straws to drink water in space. It's a clever solution, don't you think? Cool, huh? Round and round we go. Surface tension in action. Now let's talk about surface tension. Surface tension is like a thin, invisible skin on the surface of water. It's what makes water drops round. On Earth, gravity is stronger than surface tension, so water spreads out. But in space, surface tension is in charge. It pulls the water molecules together, forming a perfect sphere. Think about blowing bubbles. The soapy film that makes the bubble is held together by surface tension. Water in space acts a lot like a giant soap bubble. Section 4, Sticky Situations, Adhesion and Cohesion. Water likes to stick to things, that's adhesion. It also likes to stick to itself, that's cohesion. In space, adhesion and cohesion can cause some interesting effects. For example, if you were to touch a floating blob of water in space, it would stick to your hand. That's adhesion at work, and because of cohesion, the rest of the water would follow, forming a watery bridge between you and the main blob. These forces are important for astronauts because they need to be careful about how they handle water in space. Otherwise, they might end up with water droplets floating all over the place. Section 5. Water on the move, capillary action. Ever seen water climb up a straw? That's capillary action. It happens because of adhesion and cohesion. Water molecules like to stick to the sides of the straw, adhesion, and to each other, cohesion. In space, capillary action still works, but it acts a little differently. Since there's no gravity to pull the water down, it can travel much farther through narrow spaces. This is important for growing plants in space. Astronauts use special containers where water is drawn up to the roots of plants through capillary action. Section 6. Water in space. A precious resource. Water is essential for life, and that's true in space too. Without it, survival would be impossible. Astronauts need it to drink, to keep clean, and to grow food. Every drop is vital for their daily activities. But getting water to space is expensive and difficult. Each launch carrying water adds significant cost and complexity. That's why scientists are working on ways to recycle water on the International Space Station, ISS. This innovation is key to sustainability. They even clean and recycle the astronauts' sweat and urine. This closed-loop system ensures no drop is wasted. It might sound gross, but it's essential for long-duration space missions. Without it, extended stays in space would be unfeasible. Understanding how water behaves in space is crucial for future space exploration. It informs us about fluid dynamics and microgravity. It helps us design better spacecraft and life support systems for astronauts. These advancements pave the way for deeper space missions. So the next time you see a drop of water, remember, it's a tiny reminder of the wonders of space. Each drop is a testament to human ingenuity and the quest for knowledge.